Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, it's going to be part 3 of the Ti99 repair series. This is the motherboard that I've had so much trouble with, and I'm going to try to fix it, hopefully in this episode. Okay, let's get right to it. So if you haven't seen parts 1 and 2 yet, I'd recommend you watch those first, as this is a continuation of those parts. Now, this is the motherboard that I have been working on, Ti99 4A. It was a donation from a viewer from a mail call a ways back, and I still can't get this thing working. So far, I have socketed both ROM chips, both of the SRAM chips, these 3 8 to 16-bit bus converters, and of course the video chip was already in the socket, as were the GROMs. In the last part, I confirmed that the 2 ROMs do read properly, at least in the TL866 MiniPro. Using some adapters I made, I actually successfully read these in and compared them to ROMs I found on the internet, and they compare perfectly. I know these 3 ICs are working, and when I switch around the RAM chips, it seems to have no effect on the strange things I'm seeing on the oscilloscope. So I kind of fear that there's either something wrong with the CPU, or perhaps both of the graphics chips I have are bad. One of the things that really drove me crazy is I lacked any good quality schematics for this machine. This was a printout from the PDF I was referencing in my last video, and it is so blurry, it's so hard to read. You just can't really hardly make any heads or tails of anything, especially the U markings on the chips, where it says like U611, U610. You almost can't tell the difference from one to another. So it's very, very difficult to rely on these schematics. So I have gone into the office where I had some of my retro computers and I picked up my Ti99 4A silver version, and this computer works. Well, it should work at least. So I'm going to use this to actually help troubleshoot this problem by taking some of the chips off of this motherboard here that's not working, and at least I can confirm for sure like the graphics chip works or doesn't work and the GROMs work or don't work in this. And I might go as far as to socket some of the chips in this machine so I can test the SRAM chips in here, for instance, but we'll see if it comes to that. All right, first off, I want to test this machine out just to make sure that it actually works. All right, video cable and power is plugged in. Let's turn this on. Okay, there's the beep sound that's normal, and there we go, Texas Instruments home computer. So this is the title screen or whatever it was called in the service manual that pops up when you first power it on. If you push a key, you get this, and if you have a cartridge plugged in, it will allow you to select either between basic or the cartridge, but since nothing's connected, we'll just hit 1, and this should take us to the basic prompt, and there it is, looking good. My friend Dave donated this computer to me a few years ago, and I haven't really used it very much because I actually don't have any cartridges for it, so there's not a whole lot you can do with the Ti99 without some games and cartridges. So I set the machine aside to look at a future date, and I guess the future time is now. It was 1982 when I got my first computer, which was a Commodore VIC-20, and in 1983 I met a friend in school who had a Ti99 4A, and I remember going over to his house and we'd play games on it, and I remember being quite impressed by the capabilities of this machine, especially compared to the games I was used to playing on my VIC-20. Now, I don't remember thinking much about the aesthetics at the time because I think I was 8 years old, and what 8-year-old cares about stuff like that, but I do remember thinking that the graphics on the Ti99 definitely seemed like an upgrade over my VIC-20, and considering this machine was actually older than the VIC-20, that's a pretty cool compliment actually. And if I turn off the computer and I turn it back on, listen for the sound chip coming on, making those tones, and then getting initialized by the CPU, which immediately turns it off, and then you'll hear the system beep. This was a process described in the startup sequence from the technical PDF that I was looking at. Take a listen. So you heard that first initial beep, then there was silence, and then there was a system beep. So that's working exactly as described by the technical manual. Now, I've never opened this computer up before, but it's interesting to take a look at the bottom here. Texas Instrument 99 4A computer, model number PHC004A. Serial number on mine is 7236270. And over here on this plate, it says LTA 1363 or 6083, I can't tell. Assembled in USA with domestic and foreign components. Program and Data Contents copyright 1979 and 1981. All right, here is the computer. Keyboard is still attached. I'll unplug this. I heard there were a couple different types of keyboard. One type with the membrane and one with the circuit board. Well, obviously I have a circuit board, so that's good. There's a TI logo made in Korea. It says Futura. I was curious if the Alps keyboard is interchangeable, and I just wanted to check the mounting tabs, and they look basically the same. And the connector is very similar, so I would say that this Alps keyboard, of course, once it gets new key switches, would work. Although these black keys wouldn't fit on this. I'd have to use the brown keys in the black and silver computer, which wouldn't look super great. All right, so the RF shield stuff is held together. By the way, this is weird. Oh, this was stuck on with this rubber. Ooh, and it rusted the shield there. So on the other one, this had double-sided adhesive and it was stuck down on the case, and there was this rubber foot. But the rubber foot had adhered itself to the RF shield on there and kind of peeled off, made the whole thing hard to take apart. So the RF shield is held together with screws and nuts on this side. So I'm just gonna pull this apart. So you'll see this is the motherboard that works and the RF shield, and this is the graphics processor chip here. And as you notice, there's a large piece of metal that is actually attached onto that, and there's a bunch of this white compound, which is hard as a rock. But originally that was to transfer heat from that chip into this top cover. So that's kind of a cool design, actually, turning this into an actual heatsink. This will undoubtedly work better than the copper finger that rests on the chip on a lot of Commodore 64 machines. Those really don't work well. But this, on the other hand, is actually a pretty good solution. Video display processor is nicely cleaned up. That stuff was really hard to get off, and they put so much on there. But anyhow, I'm going to use the original power supply that came with the black and silver machine, which is one of the 4-wire types. And I just want to make sure this computer is still working. There we are. Oh, yes. Okay, good. Whew. You never know when you take something apart, and especially when you remove a chip, put it back in, that you might have broken something. So it's really good just to see this works, because I'm really afraid of screwing this one up as well, so that my other TI has no chance of getting fixed. I'm just checking the voltage rails really quick, and the 5-volt one on this one is 5.2 volts. It's a little bit on the high end as well, but not as bad as that other one. The -5 and the 12 look good on this power supply. Comparing the two motherboards is not a huge difference. The color of the PCB is a little different. This is the one that's not working, and it has a bit more of a green solder mask on it. The components all seem generally the same. Unfortunately, on the new one, nothing is socketed except the VDP and the 3 GROM chips and the sound chip, so that's the same as originally what was on this other motherboard. This side 9-pin connector is the brown beige color of the other case, of the new case, and the other one has a black one, but for whatever reason, this one on the back is black on both of them. So first things first, this is the graphics display processor that I got in the mail call from T. Maloney. I want to test that on here, and I want to test this one that's also on the black screen one and see if both of these are working or not working. Before I do anything, I'm going to put a check mark on the working VDP just so I know for sure this is the good one. Although this one has the TI logo just as the letters TI, with a regular font, while these other ones actually have the proper Texas Instrument full logo on it. Anyway, let's plug in the VDP that T. Maloney sent me. This was the mail call one. See if this one works. Here we go. The computer booted up at least, but we certainly have a garbage screen. This could be due to bad contact on the socket though. So I'm just going to reseat this again. Oh no, okay, so putting it in right now, I just bent the heck out of one of the pins. So that would explain why it wasn't working. Let me try to fix this. If I do break this pin off, I can always solder a new one on like I already did the other one on here. Okay, crisis averted. That pin, it looks okay. So I'm just gonna be a little more careful. All right, it's in. Let's try that again. Oh yes, okay, good. No damage done. So that's awesome. How great is that? This spare VDP is actually a good chip. Well, at least it shows this screen. Maybe there's further testing I can do to really see if it's working, but at this point, without any kind of cartridges or whatnot, I can't push it to its limit, but I'm glad to see a startup screen. Okay, so that chip is out, and I'm going to try this other one. This was the one that was included with the black screen machine. All the pins look okay on this. They're a little dark, like with oxidation or whatever, but should still work, I think. And it works as well. Double thumbs up. Okay, so for easy chips to try, that is the 3 groms and the sound chip. I can swap those over from this other board and test those out. So first I'm just gonna put little tiny check marks on these groms, just so I know that these are the good ones, and the sound chip, because it seems to be working. And I will draw, and I'm gonna put numbers on these 1, 2, 3, and 4. 4 for the sound chip, so I know which order those go into the motherboard. The 3 groms and the sound chip are out of the working motherboard. Now, I am really curious, if I turn this on without those in there, what do we get exactly? I know the VDP is required for the thing to do anything, but let's just give this a try without those. So we don't even get the startup screen. So black screen is a symptom of having no groms in here. Now, of course, I need to look at the oscilloscope to see what all the signals look like without those chips, if it sort of matches that frozen state that we're getting on this one. But how interesting would it be if these groms were the problem? First, I'm going to swap the sound chip over from the other one so I can hear if it's just locking up and not initializing the sound chip. So here we go. Let's try it. Look at that. Same thing. So these are the groms from this motherboard, and I have to admit that one of the pins was bent out, so it wasn't in the socket, and this one has a pin that's mangled. So I'm straightening the pins out, and I certainly just need to be more careful. I've never had this much trouble inserting ICs into sockets where I kept bending pins. So the order these go into the motherboard is important. It's 5, 6, and 7. The part number on these chips is CD2155, ANL 56, 57. Same part number, just with a 5, 6, 7. So it's 5, 6, and 7. That's the way I took it out of the working board. That is the way it was installed into this one. So I'm just going to add a little Deoxit here as lubricant, because these sockets are very scratchy. Okay, so the groms have transferred over. Let's see if this works. Oh, well, would you look at that? The groms are not the problem. Those are working as well. Okay, so I have the non-working board and I have lots of chips removed. The VDP is removed. The bus 8 to 16-bit converters are removed. Groms are out. Sound chip is out. And the 2 SRAM chips are out. In fact, all I have in here right now are the 2 EPROMs in the adapters that I made. And what I've done is I've gone ahead and I've flashed the EPROMs with some new code. Well, actually, I erased them. And when you erase an EPROM, what you end up with is an EPROM that's just filled with all Fs. The reason why I did that is because any address you access in these EPROMs is going to result in every data bit just being high. I figured that would be perfect for diagnosing issues to see if any of the lines were being shorted to ground or any other strange things were going on. Now the VDP is out because it is connected to 8 of the 16 data bus lines, and I wanted to make sure that the CPU and the ROMs were the only things on the 16-bit data bus. I even went so far as to check some of the lines and tone out where I found them, just so I was 100% sure that like these bus transceivers up here were connected, the VDP, the CPU, the RAM, the SRAM, and the ROMs, and that the data lines weren't found on any other chips anywhere else on the board. And sure enough, that is the case. I'm also using the power supply from the working TI just in case there was something wrong with that causing issues. The oscilloscope is ready to go, and I am going to start probing. I'm going to power on this machine. It's on data bit 0, and I turn it on, and it basically goes to high. You see a little bit of weird activity. Okay, it was just for an instant, but it does go high. And yeah, even though it's a little jaggy at the top, that's fine. That's just because things are going on the bus with the CPU probably. But generally, it's held high, which is just what it should be doing. When I go through these pins, they all basically look fine, and they're all high, except that one doesn't. Let me keep going. That's fine, fine. Yep, that's good. And that is good. That's all 7 on one side. And then on the other 16-bit, it does this, where it goes high for a second, but I think that might be okay because every single data bit is either like pulsing like that, or it's held high entirely. So this is the chip enable line on one of the 2 ROMs, and it drops down to ground here, which turns on the chip. Let's check this pin on the other one. And this is the chip select on the other line, so it's also dropping down to 0. And incidentally, this seems to match that pulse that we're seeing on one of the chips. Here's one of the data bit lines, and this pulse probably coincides to the chip select on the ROM. Let me hook up a second probe so we can just validate that. All right, so what you're seeing on the top here is the chip select line going to the ROM. So the ROM should only be outputting and driving the data bus when this is low. So we should see a pulse probably around here on this yellow trace when I connect to the data bits that are being driven by the ROM chip. And there we go. Right here, the chip is being instructed to turn on, and it's driving the bus to high. That's perfect. Let's go through all the lines real quick, and I'll just check to see if they look good or bad. That's good. That's good. That's weird. It's high all the time. So even when the ROM is not instructed to be outputting, the CPU is holding it high. Now keep in mind, these are EPROMs. I know these EPROMs work perfectly. So you see the little spike here where it's driving it, but why is the bus high the rest of the time? That one looks good. That one looks good. That's fine. That one's fine. Let me check the other socket. So that one's high as well. Why? All the time. High all the time. High all the time. Okay, so this is the one that looks really screwed up. Let me turn the power off and back on. See that behavior? That is, something's very wrong there. That's not normal. This right here is the ROM driving the bus high, but then what is this weird taper, and why when I turn on the computer does it slowly drop down? And it's very stepped as well, which I'm thinking probably coincides with the clock cycles into the CPU. The next bit is all high, so that's a bit strange. That one's all high as well. So is that one. And finally that one. So on this socket, almost everything is high. I'm going to power cycle it real quick. Notice it has that weird settling. So I power cycled it and notice there's no more chip select. So of course there's nothing happening on the bus here. It seems like the CPU is not starting properly because there's some circuitry that decodes the address bus, and that's what enables the chip select line. And right now we're not getting anything. Let me just quickly check out all the data bus lines, see if they're all low. Yeah, every line is low. So if I power cycle the computer again, same thing, it's not even running. There we go, started up that time. Still seeing this strange behavior. Look at that, how it settles when I turn it on. That's just weird. And then this one, what is happening here? Prompts, I think what I'm gonna do is take this air duster, turn it upside down, and spray the CPU. I'm gonna cold spray it just to see if that has any effect on those outputs. Because remember, at this point, nothing else is on the data bus except for the 2 ROM chips and the CPU. Nothing else. Everything else is disconnected. So seemingly that weird behavior has to be coming from the CPU. Okay, I want to cold spray the CPU, but check this weirdness out. I don't understand what's going on with chip select. It's all over the place, but let me try to get this to lock on. So we're getting multiple chip selects now, and then this is one of the bus lines that originally was just all high all the time, and now we're getting this weird thing that's moving down to 0 randomly. And you know, to be honest, what happens when the chip select lines like this, it should go up, go up and then be flat along the bottom. And instead, well, okay, it went back to the way it was. Let's just shrink this down a little bit, see if we're seeing anything weird. Nope, everything is looking like that. So what's changing on this board? All right, well, let's monitor this line, and I'm going to cold spray the CPU. And let's see if we see any changes in the behavior. Oh, wow, look at that. Look at that. As I cold spray the CPU, it's completely changing. Look, that's almost normal right there. That's exactly what we should be seeing. The CPU is covered in ice right now, by the way. Let me check some of the other lines. That looks normal. That one is still high. That one's high. That one's normal. So you saw it as I cold sprayed it. it fixed itself. And there's the CPU covered in ice. Oh, it's freezing cold. And I'm going to let it warm up and see if it actually starts to get worse. But that certainly clinches it for me that the CPU has failed. There's something wrong with it. And that's what's causing the bus problems where I'm seeing stuff staying high. And that is clearly going to prevent this thing from working. Look, it seems to be getting worse. Let me expand this a little bit. Look, it's degrading right in front of our eyes as the CPU warms up. What I'm going to do is I'm going to take the hot air gun here and I'm going to shoot hot air at the CPU. And we're going to see if it gets worse as I heat it up. Oh, yep. Direct correlation. Look at that. I'm also drying any of the liquid that's on the board because there's some condensation from the CPU being so cold. And look at that. As I heated it up, it's gone back to not working. And also notice that the chip select has gone back to just a single pulse. So this is the pin that was kind of marginal before. And look at it. It's looking a little screwy. Let me put heat to the CPU and see if it worsens or gets better, or doesn't really seem to be getting worse with the heat. I have one idea. I wonder if this is a problem maybe with some like physical issue with the circuit board. It's quite possible. Remember, this Ti99 had suffered some physical damage. It's the brown one. Had those cracks in the case. What if there's a problem on the PCB itself and I just need to like twist it or something? So I'm going to probe this and I'm going to start twisting the board, seeing if it gets worse or better in any kind of way that matches up with the twisting force that I apply to it. So right now I'm not doing anything, I'm just probing. And I'm twisting the board, especially around the CPU. Doesn't... Like if I don't touch it, it's moving back and forth, and when I do touch it, it's moving back and forth. I don't think this is a problem on the PCB. It just, as it changes here, as you watch it change, it doesn't seem to coincide to anything I'm actually doing physically to the board. I'm just going to try one more thing, and I'm going to reflow the solder on every pin of the CPU from the backside, see if that changes anything here. And we've reached no change at all. Look, it's still doing this weirdness. And that's on bit 0. If I go to the one that was always kind of doing this, and it's yep, still doing it. Well, I think that's it. I'm concluding that the CPU is faulty on this motherboard. There's really no other explanation for the behavior that we're seeing, especially the fact that the cold spray kind of makes it work normally again, at least partially. So the only logical thing for me to do at this point is to remove this CPU and install another one. I've ordered one from eBay. Let's take a look at what's inside this package. So there we go. Here's the replacement TMS9900NL. It's made in 8327, so 27th week of 1983, also in the Philippines. And this one here, the original one on the board, was from the 23rd week of 1983, so very similar vintage. Although I can tell from these pins that this has been desoldered from another board, probably another Ti99 at some point. I'm going to have to desolder this chip, and I will also have to remove these two wires. At least I'll take them off on one side so I can flip them out of the way. and then I will need to install a socket, and I don't have a socket that's large enough. So I'll use 2 rows of these pin socket things, and that will give me an ability to plug in another CPU. Okay, the pins are in, and I resoldered these 2 wires. I unlooped the little loop that was on them just to give them a little more range, I guess. What's the word? A little more space, so I can slide the new CPU in and push it down. I think it's time to reinstall some of the IC. This right here is the CPU I removed. I drew an X on it so I wouldn't confuse it with the one that I just bought, which was this one right here. I did draw on the board with a Sharpie the notch orientation, so the notch goes to the left, which is right here on this CPU. So now it's going to be a trick to get this in here, because these round hole pins that I installed are always a little difficult to get things into them, especially if the chip legs are slightly mangled. And if you push too hard, you'll end up just bending them. So I'm going to have to fiddle with this a little bit to try to get every pin aligned correctly so I can push it into the socket. Okay, the processor is in. That was extremely difficult. I took it out so many times. Every time I'd get everything in, one of the corner pins wouldn't be in right and it would fold over. All right, and all the rest of the chips are installed. It's now time to try this thing out on the power supply and see if this works. Okay, here we go. Moment of truth. Oh no, it's still not working. All right, well, let's take a look at those data lines and see what we can see. Okay, I've done some troubleshooting and I fear that I have caused some destruction on this board. So what I started doing is I started scoping the signals on the data lines and everything looked good until I got to this one right here. This line was running at 12 volts, not 5 volts, but 12. So I checked the data line with 12 volts. I find it over here on the CPU. It's one of these, let's see. There we go, that one right there. It's not shorted to its adjacent pins. It's just that pin right there. And over here is the RAM, and the 12 volt line is this pin right here. It's the top right in this orientation. And sure enough, we have a full short between this data line and 12 volts and right here on the CPU. Now, what exactly happened? I'm not sure. I'm going to pull the CPU out and I'm going to take a closer look, but I guess somehow I have caused a short to 12 volts on that data line. And unfortunately, I ran this with the video display processor in, these bus transceivers, the ROMs, the RAMs, everything. Now, I think the video display processor might have been saved because I'm pretty sure this runs off of data lines 0 through 7 and is not connected to the upper 8 bits of the data line. So that chip might be okay. Probably one of these is bad. And I can't imagine the ROM and the RAM chip and the CPU for that matter all got 12 volts on that pin, and that's not going to be good. So I just got to take the CPU out at this point, and we're going to take a look at what we see happening underneath. Maybe I got a pin bent over, something like that. Okay, actually, no, none of the pins are bent. So that's not the problem. And now that the CPU is out, let's take a look if we still have that short. Wow, so obviously I caused some kind of short on this, soldering that together, and I'm not even sure what I did. I know I put these wires back in the right place. All right, time to do some close inspection of this board, but I'm not holding out hope. And I found the problem. Okay, so this is the data line here that has the short. Now I was looking all around here and everything was fine on this side and on the other side of the board. But then I traced this trace over here, and it goes down here and right here through these pins, and it's shorted right there. And this is obviously a 12-volt line right there next to it. And unfortunately, this motherboard doesn't have solder mask on these traces as they pass by these pins. And as I soldered on the pin header, I bridged this and I didn't notice. And the worst thing is, as I was soldering this, I noticed those were very close together, and I tried to be extra careful, and I went back and I thought I looked carefully, but it's such a small problem that I really had to put the magnification on maximum with my goggles here to see it. So I'm gonna try to fix this. And I mean, there's a miracle chance that this might possibly work, but I doubt it. I really doubt it. So let's check there, and let's check over here, and yeah, no more 12 volts. Oh my God, I'm just an idiot. I really should have just checked all of these data lines first to make sure that none were shorted to 12 volts, because I know 12 volts runs through this and it's dangerous. All right, all the chips are back in. I'm gonna try turning it on, and I'm gonna look with the oscilloscope at that data line I put 12 volts into to see if it's even working. But I'm sure there's carnage on here, like some of these chips are bad, so I don't think this computer is gonna boot now for sure. But let's just check it out. I mean, I guess miracles can happen, right? Okay, so that looks okay, right? That looks like something's actually happening, but I fear that that is not good. Let me go to the data line that's got 12 volts on it. Definitely looks screwy. All the other signals are good. I'm going through the other data lines. Everything is fine. So I basically, like I said, I killed that one data line with my stupidity. Yeah, everything else is good. It's literally just that one pin that is now looking very screwy here and not correct. Damn it. So I am so disappointed in myself that this happened. I'm gonna try to figure out which chips are damaged by the 12 volts, if not all of them. I can switch out the 74 logic chip that's damaged. I can reprogram the ROM that's damaged, and the SRAM I just don't have another one of. I can swap these around and see if it changes, and then if the CPU is bad, I guess I need another one. Oh boy. I've done some testing. First off, this is the ROM chip. It was in this socket here that would have been hit with the 12 volts, and it seems to be working okay. It reads fine with the MiniPro. I can read it out and validate and verify the chip, and it seems fine. Now, I mean, it still could be damaged, but I don't think it is. Now, these are the 3 logic chips that were in here on the motherboard. I just swapped them out with new ones just to check. But these 2 chips, which is the 244 and the 245, this chip and this chip, those check good in the MiniPro. You can validate those types of chips. This chip here, which is the center one, is the 74LS373, and this one no longer tests good in the MiniPro. It shows a problem on one of the data lines. And it's this pin here I have the probe on that is connected to the data line that got 12 volts. So this chip definitely got 12 volts on that pin, which is probably what killed it. Now the 244, which is this chip, did also get 12 volts on this pin right here, but it seems to be working okay, but I have put new parts in just to check. So the SRAMs, I think, came out unscathed. I don't have a way to test these, but I think they're all right because I can swap these around. So this pin right here is the one that got 12 volts, and I see strangeness on the oscilloscope, right? But when I switch these 2 chips around and I look at this pin over here in this socket, which of course, this is the chip that got the 12 volts, I swapped them around already, I see normal signals on this pin. I'd imagine if this chip got damaged, we wouldn't be seeing completely normal activity on this data pin. But swapping these chips into any configuration, the bad pin is always this one that looks bad, and I really think that's coming from the CPU, which I have damaged. I did go ahead and put the original CPU, the one I took out of this board, back in here just to see if it looked like the same problems when I originally had this chip in there. And absolutely, all the data bus lines and everything just went back to looking very screwed up and not working. So this CPU definitely is bad. And this CPU, I'm pretty sure worked perfectly, except I ruined that one data bus line. So in real life, some time has passed since I've actually worked on this board, and the Ti99 Part 1 video came out, which a lot of people have watched. A viewer, Sam, got in contact with me, and he said he was going to send me some Ti99 parts so I could hopefully try to get this board working. I'm always pretty far behind on my mail call packages, which is why I asked Sam to write on here to let me know that this was the package he sent, because otherwise it might go into the pile and I wouldn't get to it for a month or something like that. Sam writes, Adrian, thank you for providing me with hours of entertainment. I love your channel, especially your computer restorations. Even though I'm not as old as you, I still have a love for retro computers. My first computer was a Ti99, given to me via a teacher who had friends who was cleaning out his basement. Hey, that's awesome. I've of course modded it with a reset switch and other stuff. As we both know, the hobby business can be very expensive and it's good for us to stick together. Anyway, thank you very much for all the amazing content. Thank you very much, Sam, for those nice compliments. And the generosity of my viewers continues to just blow my mind and amaze me. All right, let's see what we have here. So we have, one of the SRAM chips, MCM6810P, and then this one here is C2E011. That is one of the 2 ROM chips. So of the 2 ROM chips in my motherboard, I think this is the other one, the one that did not get subjected to 12 volts. So I don't know if that one's bad or not, but it could be, so who knows? All right, what's this? This looks like we have additional key switches for the Alps version. It is absolutely fantastic, Sam. Thank you. SKCC switches to replace the at least the 2 that are missing from that other keyboard. I took them out because they were snapped. I also don't know if any of the other ones are broken. So he actually sent me a pretty big assortment in here. There's about probably 10 or 15 switches. Awesome. Oh, top man, this is the power switch. This is the beige case that this motherboard came in, and this switch was missing entirely. So it looks like, well, this has to go in from the underside, but that's the missing power switch that I would need to actually make this a working Ti complete in the case. Okay, what else is in here? This is a load of goodies in here. Oh, wait, what is all this stuff here? He has written on here, Ti99 multi-cart parts. Ti99 cart 64K. From hexbus.com. It says original concept, mainbyte.com. Special thanks to S. Cooper. Wow, this is amazing. I don't actually have any cartridges for the Ti, so even if I got it working, I didn't really have any way to test. But with this, I will easily be able to build up a cartridge. Okay, I'm amazed. There's something else in here. This here is the Flash ROM 99. And I guess this allows us to have a whole bunch of multi-games or something. I'll have to go investigate that. All right, the Ti99 side port breadboard adapter. So I think you solder the side port connector onto here, and then it allows you to connect a bread bin for more easy prototyping of Ti99 expansion accessories off the side connector. All right, and then we have 2 more things here. There's a tiny URL to link to this, Rev2. The UHS Mini. What does this thing do exactly? I will have to go look that up. It looks like it takes a teensy, but there are 2 of these PCBs. Oh, it says right here, he has writing here. Ti99 USB keyboard adapter. This here appears to be a clock, Frederick Reel 2, Ti99 RS2 HDX DSR board. Is this some kind of a serial board or what? I guess I'm not quite sure. On the bag here it says HDX for serial card. Okay. And the last one says side port 32K expansion. So there are some of the side port connectors. And here is a side port card, so it would connect, this would connect onto there. And then this here is a 32K SRAM chip and a couple DSLogic support chips. And that gives this thing 32K of RAM directly mapped into the CPU, unlike the 16 built-in K, which are mapped into the video RAM, really slow to access and whatnot. I have seen mods actually to install this internal to the unit itself, so not external hanging off the side port like this. Basically, you put the same chip in a couple of these logic chips, and you solder it directly into the motherboard. And here's a part I had ordered myself. In fact, it was from the same place I ordered the dead CPU. I went on eBay, and I ordered a CPU, another CPU. So now I've bought 2 CPUs for this computer. And there it is. I mentioned to the eBay seller what happened to the original CPU. I told him that it got killed accidentally with excessive voltage. He told me that he is well aware of that problem. And when he personally adds sockets to his Ti99, he goes through and checks everything with a microscope to make sure there's no bridges because of the lack of solder mask. A very common problem, it seems. All right, so out with the dead CPU, the 12 volt one. I drew an X on it, but I also wrote 12 volts so I could tell it apart from the original CPU. And in with the new non-damaged CPU. Well, after a ton of fighting, the CPU, the new CPU, is back into the motherboard. I don't know what's going on because it seems the pin spacing on the motherboard is actually off slightly. Before powering this up, let me just check everything else is in. So these are the 2 original SRAMs. They are in correctly. These are the 2 ROMs. They are in the correct positions. This one should be down. That one should be up. They are good. The 3 GROMs are in. Sound chip is in. And these 3 TTL chips are in here. 2 are original. And the one that I killed, which is this one, the middle one, the 373 latch, that one has been replaced by a new one. But these are the 2 original ones from the board. VDP is installed, and that is the correct orientation. Let me just make sure these are all the right. They are all facing down, 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 down. This is to the left. CPU is to the left. And I think we're good to try this out. Okay, here we go. Oh boy, this has been such a long process. I almost feel like this thing is never going to work. Here we go. Oh, it's dead. Okay, well, let's hear if the sound is bad. Yep, sound is bad. Let me just push down on the CPU, make sure that it doesn't have a bad connection. Yeah, no change. Okay, let's quickly check out the various data lines here. Okay, that looks normal. Normal. Okay, you know what? I'm going to go right for the one that got 12 volts. Okay, so that is not good. So this is basically, trying to get a better one. This kind of craziness here, that is exactly what we were seeing on the other CPU, the one that, you know, I said got 12 volts. This sort of, this should be going up here, and it's not quite. So now I have a thought. So the new CPU is in, and yet we're seeing exactly the same thing on that data line. Now I tried putting in Sam's new SRAM chip into this socket and actually swapped them around. I tried all 3 chips, and nothing ever changes on that data line. So you know what's left? Oh, well, and I know I changed out the 373 latch. In fact, all 3 of these are new chips that work. So all that's left is this ROM chip. And perhaps the output on that data bit on this ROM chip is not strong enough to drive the bus. Now, it might be strong enough that in the MiniPro it shows up as working, but perhaps it doesn't have enough power or current to drive the bus. So to that end, I'm going to program one of those EPROMs, and I'm going to pop it into this socket, and let's see if that works. Now, there are 2 EPROMs, and I'm not sure which is which, so I'm just going to try this first one here. Let's go for broke, see what happens. Oh, that's video cable is not connected. Let's just clear everything away. Here we go, let's try again. Nope, that is not working. Okay, here's the other one. Let's get this out. This would be amazing if this fixes it. I mean, I keep hoping for something. But I think what really would be super annoying is maybe the old CPU never had a problem, and the reality was the ROM was the whole issue the whole time. Okay, that is in backwards. Good thing I didn't try it, because these EPROMs will fry if you turn them in, if you turn it on backwards. The notch goes facing that way. Okay, there we go. All right, are we ready, everyone? Here we go. Please work, please. Wait, look, it works. Oh, man. A bad ROM chip. Okay, I'm blown away. Okay, sorry for the black and white. That is just setting on the RetroTink here. There we go. I am so blown away. So blown away. Okay, I want to see, first of all, if the other SRAM chip works, the one that got exposed to 12 volts. So I'm going to take the SAM SRAM out of here and put in the two original ones from this board. Okay, there we go. Here we go. Oh, okay. I think it works. Yep, seems to be okay. So both of the original SRAMs are good. So this SAM one I didn't need. So now I want to take and put the original 245 and 244 chips back in here. So the only one that I will have replaced is the 373, which I know is bad because I tested that one on the MiniPro and it did not appreciate getting 12 volts. So I'll take these two out. Okay, the originals are back in, so I have the new 373, new as in like from 1982, new. My new ROM, I still have the new CPU and these. Okay, here we go, see what happens. Okay, it looks like it's still working. Yep, there we go. Okay, the final question is, will the 12 volt CPU, the one that I put 12 volts into the data line, this is the new one, the middle of the new ones, will this one work? Which means I will have two CPUs. Let's pull this one out of here. Okay, so that is the new one, which I know works well. Okay, the CPU that I thought I killed is back in. Here we go. Look at that, it works too. Wow, so this CPU did not get damaged, and in reality, it was the ROM that got damaged, and because I never tested it with an EPROM, I just read this out in the MiniPro. I assumed it was working, but it no longer had enough drive strength to drive the data bus. Wow. Just wow. So I can hear people asking right now, this is the original CPU that was in this machine. Does this CPU work? Was it the ROM the whole time? Before I turn this on, I am 99.99999, so many %, sure that this CPU is actually dead and was the only problem with this board originally before I killed the ROM and I killed the 373 with 12 volts. Let's turn this on. I don't think this is going to work. Nope. Dead as a doornail. Exactly as I thought. Yeah, the signals we were seeing and the cold spray and all that stuff, it just basically pointed to this original CPU being dead. Okay, so this is the CPU I thought I killed. I put it back in. I am just going to use some 99% IPA here to clean off the X I put on there and this 12 volt word here. And I will put a check mark to say good, because this CPU is actually good. I know these two SRAMs are good, so I'll check mark those. I know this ROM is good. And of course this ROM is good. I'm gonna put a sticker on there. All the GROMs are good, the sound chip is good, and these original buffer chips are good. Of course I killed this middle one, but I'll put a check mark on that as well. And one last time, just wanna make sure it's still working so I can pinch myself. Yeah, I'm pinching myself. It actually works. Well, everyone, this board is fixed. I'm very relieved that I got this working because otherwise I would really start to doubt any of my troubleshooting skills. I'm really a novice at this and I still have a lot to learn, but I feel that I at least made some right decisions with this, and then I definitely made some wrong decisions. And of course, I made a fatal decision of bridging the 5 volts, or sorry, bridging the 12 volts onto that one data line, which had the effect of killing this ROM chip and killing this latch here. So with the Ti99, if you ever do any repairs, well, this is probably goes for any time you reinstall sockets onto a board, it's a good idea to use something to inspect your work closely afterwards. And I can say I will be doing that from now on with all the boards I work on, especially ones like this that don't have solder mask right there. But it could happen even on, say, a Commodore 64. So this process for me was a fun experience. It was interesting learning about the Ti99. I actually kind of am looking forward to trying out some of these ROM boards and things that Sam sent me to check out what this thing can actually do. Anyhow, I hope you found this series interesting, and if you did, I'd appreciate a thumbs up. But if you didn't, you know what to do, you can hit that thumbs down button. I'd love to hear your comments and your thoughts about this video series in the comment section below. And of course, hit that subscribe button if you want to subscribe to my channel, and that little bell icon will notify you when I upload new videos. So that's going to be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.